Assalamualaikum. This is Mohammed Islam. My dear learners, today I'll talk about very important topics of chemistry, especially students of class 19. So first of all, welcome to the video, and I am Mohammed Islam, teacher, Cambridge School and College, and I'll talk about chemistry class 19 chapter 5. So dear students, look at the picture. This is the first picture for you, and I think you know the name of the substance. Actually, this is table salt and its chemical formula is sodium chloride. And another picture is here, and this is table sugar and its chemical formula is carbon 12, hydrogen 22 and oxygen 11. My dear students, I have a question to you. What type of compound is sodium chloride? Is it ionic compound or covalent compound? Yes, you are right. This is ionic compound. And what type of compound is sugar? This is ionic compound or covalent compound? Yes, you are right. This is covalent compound. Do you know the melting point of sodium chloride and melting point of sugar? The melting point of sodium chloride and sugar, both are the same or different? So I have a lot of questions to you. Look at the another picture. This is a beaker containing some water. My dear students, if we mix this sodium chloride with water, what will be happen here? Yes, sodium chloride will dissolve in water and produce a sodium chloride solution. And another question is, if we mix this sugar in this water, then sugar will mix with water and then produces sugar solution. Am I right? If we mix oil with water, what will be happen here? Because oil will be unable, indivisible this water. Okay, it will be not mixed with water. So my dear students, I have another question to you. Observe the two pictures. This is the sodium chloride solution. This is to metal rod, and this is the electric bulb, and this is the wire, metallic wire, and this is the solution of sugar. So the both solution are not same. This is sodium chloride solution, this is sugar solution. My dear students, which bulb will be lighted here? Sodium chloride solution bulb or sugar solution bulb? This is the most important question to you. Today I'll talk about the answer of the question. So I know our today's topic is characteristic of ionic and covalent bonds. Our learning outcome after the lesson, the students will be able to explain melting and boiling point of ionic and covalent compounds, why the ionic and melting and boiling point of the compounds are different, solubility of ionic and covalent compounds in water, and finally electric conductivity of ionic and covalent compounds. So my dear students, follow it. The compounds consisting of ionic bond is called the ionic compounds. And there are some ionic compounds here: sodium chloride, calcium chloride, magnesium oxide, calcium oxide, potassium chloride, and magnesium chloride. These all are ionic compound. Why these are ionic compound? Because sodium chloride made by sodium and chlorine. Sodium is a metal, chlorine is a non-metal. That's why it is a ionic compound. Calcium chloride made by calcium and chlorine. Calcium is a metal, chlorine is a non-metal. So these are ionic compound. Similarly, magnesium metal, oxygen non-metal, calcium metal, oxygen non-metal, potassium metal, chlorine non-metal, magnesium metal, chlorine non-metal. That's why these all are ionic compounds, because this compound consists of ionic bonds and made by a metal and non-metal. And thus the compound consisting of covalent bond is called covalent compounds, like water. This is water, ammonia, hydrochloric acid, methane, ethanol and methanol. These all are covalent compound. So I have to see a crystal of ionic compound, and I have chosen the sodium chloride compound. So I will show you the bonding process of sodium chloride. So this is the atom of sodium and only one electron at outmost principal energy level. My dear students, I think you know that if sodium donates this electron, then its electronic configuration will be like 1s2 to 8 neon. That's why sodium will release this electron. On the other hand, this is a chlorine and only 7 electron at outmost principal energy level. If chlorine receive a electron, this chlorine will be converted. This chlorine will gain the electronic configuration like inert gases, argon. That's why sodium will release this electron. Sodium donate this electron to chlorine, and sodium will be converted to positively charged or cation. Hence, this chlorine has received this electron from sodium. This chlorine will be converted to negatively charged or anion. This positive charge and negative charge bond to each other, create a bonds, and the name of this bond is ionic bond and produce sodium chloride solution, sodium chloride compound. This is an ionic compound, and this is the substances what I was saying in the previous slides. Okay, and the crystal of sodium chloride is like this. My dear students, if you look at the structure of the ionic compound sodium chloride, it will be very clear to you why the ionic compounds remaining solids at a normal temperature. This is sodium indicated here, red ball indicated here sodium plus ion, and blue balls indicated here chloride ion. Okay, green, not green, this is blue actually. And this is, if you consider this is sodium, so here 1 chlorine, 2 chlorine, 3 chlorine, and samely there are another 3 chlorine in another part. So if we observe the crystal of the sodium chloride, here is a 6 ion around every ions. This is sodium 1, 2, 3, 4, 5, 6. So there are 6, there is 5 and 6. So there are 6 ion surrounded the every ions. Okay. So why the melting point and boiling point of ionic compound is higher than the melting point or boiling point of covalent compound? So ionic compounds contain positive and negative charges which remain tightly connected to each other. Many such positive and negative charges organized in an ionic compound in their dimensional way to create crystal. This results in higher atomic forces among them, and they make it thought to alienate them from each other. Therefore, they require higher amount of energy to melt or boil. That's why the melting point and boiling point is higher than the covalent bond. If we look at the covalent bonds, interatomic force in covalent compounds is comparatively weaker, as it is constituted because of van der Waals force. Therefore, they can be boiled or melted with a lower amount of heat energy. So that's why the melting and boiling point of ionic compounds is greater than, comparatively higher than the melting and boiling point of covalent compounds. So my dear students, I think it is clear. So if we go to the next slide, the structure of water. If we want to know the solubility of different types of compound into water, first of all we have to know the structure of water. You know, water consists 2 types of atoms, hydrogen atoms and oxygen atom. So this is oxygen atom and only 6 electron outmost principal energy level. Okay, so if the oxygen want to gain electronic configuration like neon, it needs another 2 electrons, and this is hydrogen and this is another hydrogen atom. The both atoms of hydrogen share this electron with the 1 electrons of oxygen and produce a oxygen hydrogen bonds. So there are two oxygen hydrogen covalent bond. Okay, this is a oxygen hydrogen covalent bond and this is oxygen hydrogen covalent bond and produce H2O. My dear students, if you want to see the structure of water, there are two electrons. These two electrons and these two electrons are same. There is a electronegativity of oxygen. It is the attraction force of oxygen. It has a higher electronegativity than hydrogen. I think you have read in the periodic table chapter what is electronegativity. This is the bond pair electron. This electron are shared by hydrogen and oxygen. So oxygen has some probability to get the both electrons to them. So that's why the oxygen will formed a negatively charged and hydrogen will formed positively charged. So here is created a negatively partial negative and partial positive charge, and this is called pole. This is the negative charge pole and this is positive charge pole. So that's why O is 2O. Water is a polar solution. What is a polar compound? So that's why we can say this water is a universal solvent. So dear students, this is sodium chloride. If we add sodium chloride with water, what will be happen here? Okay, sodium and chlorine, this positive and negative charge attached to each other by a statistical electric force. And when we add this sodium chloride with water, then the negative charge of water, the partial negative charge of water attack the positive charge of ionic compounds. This negative charge of water attack the positive charge of ionic compounds, and the partially positive charge of water will be attack the negative charge of ionic compounds, and then this sodium will be come in the water and chlorine will be dissolved in water. That's why the ionic compounds are easily dissolved in water. On the other hand, the covalent compound has no positive or negative charge. That's why these are not soluble in water. But some covalent compounds has polarity, because there is a sentence, like dissolves like. If we follow this, ionic compounds will be dissolved in ionic solution and covalent compound will be dissolved in covalent solution. Polar compounds will be dissolved in covalent compounds or covalent solution. Polar solution. Water is a polar solvent. That's why sodium chloride will be solvent water. Okay. So my dear students, look at this. This is methane. This is the structure of methane. This is carbon, and there are 4 hydrogen around the carbon. But this is non-polar and covalent compound. That's why methane is not dissolvable in water. In the same way, this is ammonia. This is non-polar. That's why, and this is covalent compound. That's why it is not dissolvable in water. And another one is hydrochloric acid. Look at here. This is hydrogen and this is chlorine. It is partially positively charged and partially negative charged. So hydrochloric acid is a covalent compound, but it is a polar compound. That's why hydrochloric acid will be dissolved in water. Hydrochloric acid will be dissolved in water. Why? Because hydrochloric acid is a polar compound and water is a polar. That's why polar compounds will be dissolved in polar. It is a like dissolves like rule. So look at the another picture. This is methanol. This is alcohol. This is methanol. There is oxygen. The electronegativity of oxygen is greater than carbon and hydrogen. That's why these two bonding electrons will attach more attach the oxygen, and it will be converted to partially negative charge, and this carbon will be positive and this hydrogen will be positive. Hence there is a positive and negative charge. There is a pole, two different charge. That's why this is a polar compound. So this compound will be dissolved in water. Because methanol is a polar compound. That's why it will be dissolved in water, because water is a polar. So the reason of the produce electricity. So I think this is clear. The results of produced electricity. I have another question to you. This is sodium chloride solution. If we submerge 2 rod in sodium chloride and connect it with a wire, electric wire, then this bulb will be lighted here. And on the other hand, sugar solution will be not produce electricity. That's why the bulb will be not lighted here. So sodium chloride solution produce sodium ion and chloride ion. These both ion are the main rules to carry the electricity, to pass the electricity. And on the other hand, there is this solution no ion, there is no positive ion and negative ion. That's why it is this light will be off, not lighted here. Hence, sugar can't produce any ion in solution. The students, so the mechanism, the bulb sugar solution not lighted because sodium will be go there and chlorine will be go there, and sodium will receive electrons, chlorine will give electron, and this electron will pass through the wires. And if we set a bulb, the bulb will be heated because there is a electron passing. I know that if any compounds, any substance want to pass electron, of course it have to free electrons or free ion. There is a free ion. That's why this sodium chloride solution can produce show the conductivity of electricity. On the other hand, this is a ion covalent compound. Hence, the sugar is a covalent compound. It has no positive or negative charge. That's why this solution unable to conduct the electricity. I think you have understood the methods, the mechanism of how the sodium chloride solution produces the electricity and sugar solution not produce the electricity. Okay, so my dear students, let's go to the evaluation. What is polarity? This is the first question. And second, what is a polar compound? Explain. These questions are most important. And finally, solid ionic compound unable to show electric conductivity. Explain. Look at this solid ionic compound. Yes, my dear students, solid ionic compound are unable to produce cation or anion. That's why these are unable to produce electricity. But if we melt the solid ionic compounds or dissolve in water or another solution, then it will produce ions. That's why the molten or solution of ionic compound will be produce electricity. Nice. So I have homeworks to you. Homeworks. Table salt and table sugar both are soluble in water. Am I right? Yes. But salt solution shows the electric conductivity. Sugar solution not. Give your opinion. I think you have got the points. Of course, you will write the answer of this question and this question in the video description or our group. Thank you. Thank you very much.